Your laptop has 16 gigabytes of RAM. The log file you've been asked to analyze is 2 terabytes. That's not a wait a bit longer problem. Pandas won't load it, Excel won't open it, and buying more RAM won't save you, because next month the file is 4 terabytes. So how do companies query data like this in minutes? That's what this video is about. The obvious fix is a bigger machine. That's called scaling up, and it works until it doesn't. Price grows faster than power. A machine with 10 times the memory costs far more than 10 times as much, and at some point the machine you need simply doesn't exist. Worse, one machine is one point of failure. When it dies at 3 a.m., your pipeline dies with it. So instead of one heroic machine, we take a different path. Many ordinary machines working together. That's scaling out, and it's the foundation of everything else in this course. Here's the mental flip that makes distributed computing click. Think of a national election. Nobody ships 200 million paper ballots to the Capitol to count them in one room. Each polling station counts its own box locally, and only the small subtotals travel. Spark does exactly this with your data. The 2 terabyte file gets split into chunks called partitions. Each partition lives on a different machine, and every machine has its own CPU, memory, and disk. Nothing is shared. Machines process their own chunk independently, in parallel, and only exchange small results when they truly have to. 200 machines, each handling 10 gigabytes. Suddenly the impossible file is just 200 easy files. This idea isn't new. Google built MapReduce on it 20 years ago. Map, transform your chunk, shuffle, regroup related data across machines. Reduce, aggregate the groups. It worked, but with one painful habit. After every single step, it wrote all intermediate results to disk, and the next step read them back. Like a chef who puts every ingredient back in the pantry after each cut. Spark's founders asked the question that changed the field. What if the ingredients just stayed on the counter? Spark keeps intermediate data in memory across steps. For workloads that reuse data, and most analytics do, that alone made Spark dramatically faster than MapReduce. So what exactly is Apache Spark? The project describes itself as a unified engine for large-scale data analytics, and unified is the key word. Same engine, same API, whether you're running SQL queries, batch pipelines, real-time streams, or training machine learning models. You write in Python, SQL, Scala, Java, or R. Spark plans the distributed execution for you. You never say machine 7. Take this chunk. You describe what you want, and the engine figures out how to spread it across the cluster. In this course, we'll use PySpark, the Python API, on Spark 4. One quick look inside before we write code. We'll go deep in the next episode. A Spark application has a driver, the brain that takes your program, builds an execution plan, and splits it into tasks. The actual work happens in executors, worker processes spread across the cluster, each crunching its own partitions. Driver plans, executors execute. Keep those 2 words in mind. Everything in this course builds on them. Let's make it real. Say we have web server logs, and we want the endpoints that fail the most. First, we create a Spark session. That's our connection to the engine. Then we read the logs. Notice the path ends with a wildcard. This can be 1 file or 10,000 files. The code doesn't change. We filter for status codes of 500 and above, group by endpoint, count, and sort. Here's the crucial part. When this runs on your laptop, Spark uses your CPU cores as a tiny cluster. When it runs on 200 machines, the code is identical. Nothing in what you wrote mentions machines, chunks, or parallelism. That's the promise of Spark. You scale the cluster, not the code. Now the mistake almost everyone makes in their first week. Using Spark for everything. Coordinating a distributed engine has a fixed cost. Planning, scheduling, moving tasks around. On 100 megabytes, Pandas finishes before Spark has even finished planning. It's like chartering a cargo ship to deliver a single pizza. The ship isn't slow, it's just the wrong vehicle. Spark starts winning when data stops fitting comfortably in one machine's memory, think tens of gigabytes and up, or when the same pipeline must also run on next year's 10x data. Small data? Keep using Pandas. Right tool, right scale. Quick recap. One machine hits a wall, so we scale out. Spark splits data into partitions across machines that share nothing, processes them in parallel, and keeps intermediate results in memory. That's the speed. One engine, one API, any scale, that's the power. And small data doesn't need any of this. That's the judgment. But I skipped something. Who decides how your Python code becomes 200 coordinated tasks? That's the driver, and what it does with your code is genuinely clever. That's the next episode. See you there.